once you have the biosalts, you've got an emulsified system and dietary lipases that aren't hormone regulated, they're just plain active all the time. They attack it and break it down into fatty acids. We absorb these fatty acids across the intestinal mucosa, and then we reassemble them back into fats, into triacylglycerol. So we don't have the ability to, basically those cells lining the digestive tract can't take in a whole triglyceride. But in the digestive tract, you chop off the fatty acids, you got glycerol, free fatty acids, they can be brought in across the luminal lining there, and then they're repackaged into triacylglycerol and put with proteins into chylomicrons. So free fatty acids, once they're inside, you rebuild the triglyceride. This is in the intestinal wall here, the cells lining the intestine. And they donate these triglycerides to these transport vehicles we talked about a long time ago, chylomicrons. It's the biggest of the lipoprotein particles. And that floats around in the bloodstream, delivering the fats to whatever cells need it, whether that's a heart cell or a fat cell or whatever. Just to review, this is what a chylomicron looks like. It's got polar lipids, a monolayer on the outside. This isn't a cell membrane kind of structure. It's like half a membrane, right? It's got polar phospholipids with polar groups on the outside. Your fatty acid chains pointing in here, and then the triglycerides in the center. It also carries cholesterol, that's what these guys are, and they also have specific proteins in them. Each of the lipoprotein particles carries its own signature collection of proteins on the surface. The chylomicron would have the C2, C3 proteins, B protein, and maybe a couple others.
So does cholesterol have a